to the cloud and minimize. All right. So we're on to PLS. Let's see. Stop video. There we go. Oh, you just, sorry. Stop your video. There you go. Okay. SmartPLS is, where's my SmartPLS? Right here. If you have SmartPLS, open it up. I also have slides on this in the slide folder. Let me close this and this. Save. And I'm actually not going to go through these slides, but I'll show you that we do have slides. And these slides were actually put together by a different professor. I borrowed them, tweaked them a little bit, but mostly they're not curated by me. I just put I put two slides at the very beginning. That's my contribution. And one is a link to the YouTube playlist that has 17 videos on how to use SmartPLS 3, and then a StatWiki page for references to partial least squares. And then a list of all the things we might get to today. We have a lot of stuff to do in SmartPLS because we're essentially doing everything we just did over the past 2.5 days, now in one afternoon. But you already know all the conceptual stuff behind what we're going to do, so it's just procedural at this point, how to do it in SmartPLS.
Do you recommend one versus the other?
PLS versus Amos? Yeah, we should talk about that.
Is there a difference between SmartPLS and PLS?
Oh, PLS is the algorithm, partial least squares, instead of ordinary least squares, or maximum likelihood, or something like that. So that's the algorithm name, but the software is SmartPLS or Warp PLS or PLS GUI or PLS Graph, or it goes on. There are several out there. Just like for Amos, there's also Lizral, there's EQS, there's Factor. M plus is another one. M plus, I don't know if M plus does formative models. I don't know. I'll find out.
What about R?
R can do some formative modeling, yeah. R and M plus are all syntax based though, all coding, whereas SmartPLS is drag and drop GUI. Okay, so if you open up SmartPLS, you'll see this. How many of you are going to be following along in SmartPLS so I know how? Okay. So I'll go slow enough to keep everybody up. How many of you have never used SmartPLS? Okay. Okay. So SmartPLS does not accept a .sav dataset or an XLS dataset. It only accepts CSV or DAT or TAB. Formats that you don't use. So we have to create a data set that is a CSV file. That's what we have to do first before we even get into SmartPLS. So let's do that. In SPSS, we have our data set. This, let me close a bunch of these here. Save and close. So we have the LVS data set, this one. Let's go to that chat. Let's see. Is M plus better than Amos? I've never used PLS and will be following along. M plus is different from Amos. It's all syntax based. Amos is great because it's graphical. Amos can't handle a lot of things that M plus can. If you want a list of the things M plus can do, it is here, M plus guide.
And a quick question as you do that, which data set is the one for Google Drive?
The data set we use the LVS 2018, the boot camp trimmed LVS or whatever it's called.
Trimmed?
LVS?
The one that has LVS in it. Let's see. I'll go to it right here. Data. We're going to use this one right here. Boot camp 2018 LVS.sav. If you want to know what M plus does, I'm not covering M plus in today's boot camp. I might do that next year's boot camp. But here are all the things M plus can do. CFA, growth modeling, survival analysis, time series, mixture modeling, multi-level modeling, Monte Carlo simulations, all that sort of stuff. So it can do a lot of stuff.
What is the name of the website?
Statmodel.com. That's for M plus.
Sorry?
That's for M plus, statmodel.com.
Is that file is in the data, right? In the data set?
What was the question? Sorry.
The file we're going to use, is that in
Okay,
the data set?
We're going to use SmartPLS, and the data set we're going to use is LVS, this one right here, Bootcamp 2018 LVS. LVS stands for latent variable scores, by the way. LVS. Okay, but we need to convert this .sav into a .csv, comma separated value file. So in SPSS, go to File, Export, CSV data. So we're going to create a CSV file.
Are you going to close this? Because I don't have SPSS.
SmartPLS?
Or SPSS, you're exporting it now from SPSS.
Yes.
It would take me like 10 minutes to.
Oh yeah, I'll save this CSV file where you can access it. Yeah. So File, Export, CSV, comma separated values. Click on that and write variable names to file. Yes. Save labels. No. What are we going to name it? It's going to be in the data folder, and I'll name it Bootcamp 2018 PLS. Save. So everybody should have access to that file, the CSV file, or you can create it yourself if you like. But it should be over here. Now here it is, Bootcamp 2018 PLS.csv. Might take a moment to sync. Let me know when it shows up so I know when to move forward. As a side note, lunch was awesome. We walked in the rain to the creamery. It rained and rained and rained. And the ice cream was amazing. The grill was okay, but the ice cream was amazing. Any luck?
Yeah, it's there.
It's there. Refresh. If you're on a browser.
But it's saying it's Excel.
Yeah, it's an Excel file.
Okay.
Yeah, it's just a
Oh,
.csv
so-
Excel file. If yours isn't showing up, hit Control F5 if you're on the browser, or hold Control and hit refresh. If you hold Control and hit refresh, it refreshes that browser without looking at your history, and so it'll automatically load a new page instead of using historic data. Any luck? I should have told everybody about the Wi-Fi and everything when we got here, huh? Everybody's using local Wi-Fi, right? Not like trying to use their hotspot or something. Good. No luck?
You continue. I'll try to catch up.
Okay, okay.
It looks like an Excel file.
Yeah, it's an Excel file.
Yeah, it's weird. Yeah, it's not.
Okay, I got it.
It's not showing up for you either?
No, it just showed up. I'll do it.
For you, it just showed up. For you, no show up. Did you hold, oh, you have a Mac. Command and refresh?
The good thing is PLS can work on any platform.
Right, it should work on Mac, yeah.
Amos only work on Windows.
Right, Amos only works on Windows. Okay. Any luck? No?
Just open it.
And it's in the Google Drive, right?
It's in the Google Drive data folder? Not showing up still? All right, I'll just email it to you real quick. Let's see. This will be on the video. Sorry. What's your email?
ALSUA.
There you
I'm
go.
just gonna start
We're gonna
emailing
spam you
now.
now.
I got it. There you go. See attached. Yeah.
You know what, we're gonna send you survey links. You can just fill out the
Sure.
survey.
All right, I just sent it to you.
I'm sending my surveys to February for him to, so, okay. He'll send it to-
Thinking about it. It hasn't sent yet. Come on, send. Send. There we go. It's sent. Okay.
So, if it essentially does the same thing, how come we don't use that?
Why don't we use SmartPLS instead of Amos?
Or SPSS or?
The reason we don't use SmartPLS is because until recently it has been disreputable. It's had algorithmic flaws, and there's been a great debate over whether it's valid. There's still a debate over what. In fact, I just reviewed a paper about a month ago saying that partial least squares algorithms are still flawed, and here's why. And it was a really good argument. So whereas Amos, there's no argument about whether it's valid. It's valid. So that's why. Okay.
Is there an argument about EQS?
If there is, it's a very quiet argument.
Okay.
Yeah, very few people
The
use it.
Amos looks way too complicated with all the plugins and all that.
Yeah. I've made it complicated in order to simplify it.
Yeah, he really has. He really has.
Without the plugins, it is simpler to use but harder to use. Yeah.
It's tedious to use without it.
Did you get the email? Yeah.
I did.
Okay, good. Okay, so in SmartPLS now, you do file new project if you want to start a new project. Create new project. Name this project whatever you want. I'm going to call this Boot Camp 2018. And it can have spaces in the name. I just didn't put spaces in the name. Once you do that, you'll see over here in the Project Explorer, Boot Camp 2018 or whatever you called it, and it'll have a model file and a where's your data label. So we can click this to import your data. It's going to say, where's your data? So we're going to go find that data. It's the CSV file. That's what it's looking for. You can see here, it even tells you, I will only accept a CSV or TXT file. Bootcamp 2018 PLS, open. What do we want to call it? Bootcamp 2018 PLS? Sure, that works. It imports it. It's calculating some stuff. And there we go. It's in. Yeah.
Zach, can it do a missing value to fix the missing value?
It can handle, okay, so SmartPLS 2 couldn't handle any missing values, couldn't handle any text values, couldn't handle any scientific notation, couldn't handle more than 12 decimals, a bunch of limitations. This one fixes all of it. You can have pretty rough data and it's fine. Okay. Now, it even tells you, if you go look at the output that came here, it shows you how many are missing, what the mean is, what the median is, the min, max, standard deviation, excessive kurtosis. Let me open that up. Excessive kurtosis and skewness. And so if you want, you can do a little data screening right here. I'm going to sort by missing. How about that? If I click on the missing column, it sorts it by missing. I don't have any missing, so it's zeros. I could sort by excess kurtosis. Here are my biggest kurtosis. 2. 2 is not big. So I'm good.
Why does it call out the kurtosis as having an excess adjective but not the skew?
So kurtosis is something that is fine within a certain range, but in excess of that range, it's not fine. Whereas skewness, the very label skewness implies being skewed already. Yeah, that's my guess. We can sort by skewness and see what we got. Our biggest skew is 1, -1, not a big deal, we're good. So we have now checked our normalities. That was nice and easy. Yeah.
Is that the largest or smallest?
Skewness right now, this is the largest value. Oh, maybe that's the smallest value if I sort again. 14, here it is. That's the Cook's distance though. We can ignore Cook's distances. Age is the biggest one, 1.4. Not a big deal. Let's sort kurtosis again. There we go. And the biggest one is age at 7.6. That is a big deal. But we talked about this before. Age is necessarily kurtote because it's a sophomore class. Next is the interactions between playfulness and anxiety. Interaction between anxiety and experience, I mean. And then the next biggest is decision quality, which is still less than 3.3. So we're okay. And less than 3, less than 2.8, more than 2.8. Okay, so we don't have a big deal. We already checked this anyway, so we knew that. We have good normal data. Okay. Also, you'll know this data was good if this icon up here turned green. If this icon did not turn green, if it were red, there's some problem with your data, and it would give you an error and tell you what the problem was with your data. I have not successfully triggered that red icon, so hopefully you won't either. If you don't have, I'm trying to think what would trigger it.
If you don't have all the columns have to be full.
You can have missing values.
Because well, it'll say. Like
Oh, if you have no values in a column.
If I tried to put in point 1 last night or this morning or whatever, and it says, 2 of 15 columns are missing
or blank or something like that. Yeah. Yeah. If you have no values in a column, that's a problem. Very good. Or in a row, probably. If you have no values in a row, that's probably a problem. So you have to delete those rows and columns that are blank.
Go back and do it and re-upload it.
Yeah. But.
And you can't have anything excess at the top either.
Yeah, you can't have an extra variable name with no values in it. Yeah. Also, your variable names should be single contiguous words, no spaces in them. That would throw an error. Cool. Okay. The next thing is to set up a model. So first off, what we want to do actually is say that this is our default data. Right-click this data and say select it as active data file. This will be the data it says we are using. Okay, and then double-click the bootcamp model. And you should see something like this. If you double-click the model file. That thing.
When it turns into green, then the data file is used.
Then if it's green, that's the data file we're using. Okay, now you'll see down below, let me pull this up a little bit. Oop. Come on, here we go. These are all of our indicators in our model, all the variables. SmartPLS is a latent modeling software, so we're going to create latent models. Let's go ahead and create the model that we're testing. The way to do that is to click on this latent variable tool up top. It's the circle with the little star. And then you're going to click, 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 click. We also had 2 control variables, age and experience. Now, age and experience are not latent, right? They're observed. But SmartPLS can only handle variables connected to latent factors. So we're going to treat them as if they were latent, even though they only have 1 indicator.
Sorry, I missed that. What was the star?
This latent variable button. So you just click, 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 click. It creates a bunch of latent variables. We have 8 in our model, if you don't count the interaction term. But let's go ahead and pull the interaction as well. There we go. One more. Experience. And then you need to go to the selector instead of the latent tool. Go to the selector. And we're going to rename these. So this one up top, if you were to right click it and go to rename, or just hit F2 while it's selected, you can rename it to experience. So right click any latent factor to rename it. This one is playfulness. Anxiety. Usefulness. Compuse. Info acquisition. Decision quality. Age. And frequency. Okay, I'll wait till we're all together.
You have the ability to copy and paste.
Factors?
Mhm.
I think so, yeah. If I select these, Control C, Control V. Nope. Copy. Nope. Apparently not. Edit. Nope, copy is not an option. Okay, so let me bring this all closer together so I can zoom in a bit.
Little trunk.
No truck, you can just click and drag, it's amazing. As long as you have the selector selected.
Might be the balloons or the truck.
Okay, let me zoom in a bit. Whoop. Stop. What is it trying to do? That is just weird. Zoom out. Nope, zoom in.
So to move it around, just select it.
Yeah, to move around, you just click and drag. Whee! Okay, so those are the variables. Then to get them their indicators, you just click and drag. So here's anxiety. I'm going to hold shift as I'm selecting those. And I can just drag anxiety into anxiety. There they are, all prettily formatted. Comp use, I'll drag into comp use.
I'm developing a crash on SmartPLS.
A crush, yeah. After using Amos, it feels pretty good, right?
I am seriously falling in love here.
Newer, younger model. Playfulness, we can bring playfulness in, same. So awesome.
So just shift.
Yeah, click, shift, click.
Oh,
So much easier.
It's
look
not
at
enough.
that big grin over there.
Since a couple years ago.
Did I miss usefulness? No. Oh, I got them all. And then frequency, age, and experience. So age is just one, like that. And experience, frequency. Cool. And if you want, you can hide them. If you want to just hide all these, you can right click them and say hide indicators. They're still there, they're just hiding, they're out of the way, which is kind of nice. I'm going to unhide it. Whoops, cancel. Show indicators, there we go. But you can also rotate them. So for example, if we want these on the bottom, we can align indicators on the bottom. Whee, like that. Kind of big and messy, so we won't do that.
Okay.
And left. But nice and easy. There we go. But I'm going to rotate these so they're around on the right. There we go. Maybe I'll put this one up top and this one down bottom. And I'll hide these. These aren't so important. I'm just going to hide these. Okay. So you should have something that looks roughly like this.
Kind of method. I mean, like you got all the data. How do you get to show all the reflected indicators?
How to show them?
Yeah.
They should be showing. If not, right click it and say show indicators. Yeah.
Where do you rotate them?
If you right click them,
Oh.
and then there's a line in the middle here. You can align any side you want. It's great. I like it. Yeah. Remote folks, sorry, we're going a little slow. Just trying to keep everybody up at the same speed. SmartPLS 3 is kind of nice. It gives you good indications of when you're in the right zone and when you're in the wrong zone. Red means wrong zone, green means right zone. Right now, no good. This isn't gonna run because it's all red and nothing's connected. So to connect things, we use the connect tool right here, connect, up top. And you don't click and drag, you just click, 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 click. So do some clicking. Oh, I connected experience and I shouldn't have. Whoops. Oh well. I also connected that and I shouldn't have. I'm going to delete a couple of these. If you add someone you didn't mean to, like I have a few here I didn't mean to add, you can delete those lines. I'll show you how in a moment. Oh, it's green or blue. Sorry, it's blue, which means it's time to run, or it can be run. Doesn't mean it's time to run. I added some arrows I didn't want to though. So if I use the selector tool, I can then go select the arrows I didn't want to add. Which for me, it was this line right here. Come on. This line right here. Come on. There it is, delete. And I added another line. This line right here, I didn't want to add, delete. But I did want to add a line from experience to CompUse. Okay. And if I want, I can do frequency on information acquisition, something like that. Cool. So we have a model something like this. Doesn't have to be the same, but we're pretty close. This model, notice there are some differences between this and Amos. There are no covariance arrows. Partial least squares is not based on the covariance matrix. So you don't have to covary things. Also, there are no error terms showing, but there are errors being calculated. You just don't have to display them. It's implied. Like, why do we have to show it every time if we have to use it for every single one? It's just implied. So they're there, they're just not showing. They will be calculated. Anyway, that's easy enough. Yeah.
No, I'll ask later.
Why not use this case?
No,
Okay.
that's not the question.
Okay.
I'll wait till you run it and then I'll ask.
Okay, I'm gonna hit save. So everything's all set up and saved. And now up in the calculate area, I want you to, there's a ton of options here. Multiple algorithms we can run. We can run the PLS algorithm, that's the partial least squares algorithm, or a consistent version that's consistent with Amos, consistent with Lizerl. And this is the algorithm you would run if all of your factors are reflective. If you have any formative factors, you don't run this one. But if you have all reflective, just run the consistent algorithm. There's bootstrapping PLS or a consistent bootstrapping PLS. We're not going to use blindfolding or CTA or that one or that one. Later we're going to run the multi-group analysis though. It has a bunch of other stuff that's well beyond the scope of this workshop, but you can learn more about those if you just click on them. There's actually info on how to use them and what they're for. So this time we have all reflective factors, so just hit consistent PLS algorithm. And there's some options for it that pop up. This first one says, do you want to connect all latent variables for initial calculation? Essentially like covariating everything. If we're assessing the outer model, the measurement model, then the answer would be, yeah, we should probably do that. Especially if we have all reflective latent factors. If we're assessing the inner model, the structural model, then not so important. I wouldn't check it. For now, I'm going to leave it unchecked because we're going to look at the structural model to start. In the partial least squares tab, says, well, how do you want to do this? You want to do this based on centroid, factor, or path weighting scheme. Since we're looking at the structural model, we're going to use the path weighting scheme. If we did a measurement model, we do the factor weighting scheme. Don't worry about centroid. You can read more about it on the side column over here, which one is which and what they're for. Don't worry about the stop criterion. Don't worry about the initial weights. Weighting tab, don't worry about anything here. And just hit start. It runs and it pulls up a report. But before we look at the report, go back to the model itself. Right now you see we're on this tab up here. Go back to the model tab. And here are all the coefficients. These are standardized regression weights. And the R square is inside any endogenous variable, just by default. So you'll notice something right off the bat. The R square, oh, we're missing a line. That's our problem. The R square from on decision quality is 329, but it should be higher, right? It's because we're missing the line from information acquisition to decision quality. How do we know to put that there? In Amos, we had model fit to look at, right? PLS does not assume model fit. Model fit's built on a chi-square. The chi-square is built on covariance matrices. PLS is not built on the covariance matrix.
No chi-square.
So there is no chi-square. So in order to assess model fit, it's really awkward. And in fact, the authors of SmartPLS, they've written, we only put model fit measures in here because people keep nagging us about it. We don't agree. We don't think model fit is an appropriate measure in PLS, but we'll put it in there to satisfy the customer. Anyway, so there is model fit in here, and we can go look at it. We'll look at it in a minute. But R-squares are in the middle. Regression weights are on the lines. You can even see the outer model right here, the regression weights for the factor loadings right here. You can't see any p-values, which is a little frustrating, or any indication of significance. So we have no clue if this path right here, this 256 or 265, is actually significant. But you can in the output. So if you go to the report back in this tab, you'll see there is, I wonder if I can, nope, can't zoom in here. Nope, oh well. The default view is the path coefficients, which I'll zoom into. This is a matrix from age to decision quality. Here's your standardized regression weight. Zoom out. And it doesn't give you the p-value here. If you go to path coefficients here, it shows you the amplitude of those regression weights, either positive or negative. And then if you want the p-values, you have to run a bootstrap. So let's do that, and then we'll go back and look at all these other metrics. So back to the model. Back to calculate. Consistent bootstrap. Bootstrapping will perform the calculations we need to set up to establish confidence intervals, which are needed for p-values. I'm going to make this 2,000 subsamples. 5,000 is better, but it takes a while, so I'm going to do 2,000 for today. And then everything else I'm going to leave the same and hit start. And it's going to think for a bit. Again, in the video, this is where I speed things up.
I wonder, James.
Yeah.
Between the consistent PLS algorithm with the formative, is there a big difference in the output?
If you have a all reflective model and you run consistent or you run regular PLS, typically the regular PLS algorithm will inflate the regression weights just a little bit. Yeah.
Professor, what about if I have both reflective and formative?
If you have reflective and formative, use the regular PLS algorithm. Yeah. Okay, when you run the bootstrap and it finishes, hopefully you don't end up with a bunch of errors. That has been a problem with consistent I've seen. In fact, yeah, this one didn't run properly. Dang.
So what do you do? You just run?
I'm so glad that happened, because
How do you know it didn't run properly?
so I got a bunch of NA and no t-statistic, no p-values. I've run into this problem with SmartPLS 3 many times. The consistent algorithm is not that great. When it works, it works. When it doesn't work, you get this. And I haven't asked Christian yet why that is.
So what do you just do, run more iterations of it then?
Nah, so what I'm going to do instead is just drop the consistent portion and just run the regular PLS algorithm. Yeah.
Do you think it would work if you ran like 5,000?
No, I think I'd get the same error. Yeah. So I'm just going to run the regular bootstrapping instead of consistent bootstrapping. 2,000 times, start. Yours might have run, who knows? Mine didn't work.
So let's just say hypothetically.
Yeah.
Tony decides to use this
Eh.
for the count.
I'm his grader, I think.
Would it matter?
As long
Or
as
what
he
if
covered
I-
his bases.
What if I hypothetically?
As long as you cover your bases and your grader's okay with it. Your grader has to be okay with it though. Okay, now it worked. See? Yay, it worked.
So can you repeat what was the difference between consistent and regular?
Yeah, so it used to be PLS was the only algorithm. There was no consistent algorithm. And proponents of the covariance-based methods like Amos and Liserl said, no, PLS inflates reflective models. And so the designers of the PLS software said, well, we can actually make a correction in the PLS algorithm that makes it more consistent with covariance-based methods. So now they call it PLSC, or consistent. It just doesn't always work, which is unfortunate. Yeah. Okay, but this one worked if I just did the PLS bootstrap, not the consistent bootstrap. And you can see if I expand this, if my mouse will cooperate. Okay, every path and its p-value and t-statistic. So I can sort this by clicking on the column title and see the ones with the, that didn't sort very well. Wait a minute. Well, it was supposed to sort. Still some bugs they're working out in the SmartPLS software. That's interesting. I should email Christian about that.
So if you were going to use for this SmartPLS in your analysis, you would go from SPSS doing the Explorer scoring, then onto the SmartPLS.
You could do your EFA and SPSS and then do your CFA here. Yeah.
That means that no measurement model.
There is a measurement model here in SmartPLS. It's the outer model. Yeah, and we will do a factor analysis in SmartPLS today. I just started with a regular model structural because that's easier to understand typically.
I think it is not necessary to use SPSS if you use.
If you, yeah, you could do a whole factor analysis and data screening in SmartPLS.
Yeah.
Yeah. The only struggle you'll have, actually no struggle, because the pattern matrix it produces is also unguided.
Yeah.
So yeah, you can do the whole EFA in here.
You can do the EFA.
Mm-hmm.
Yeah. Everything you can do.
Oh, the arrows, yeah, showing right direction.
Hey, Mukhtar.
Yeah, no, what I'm saying now, the outputs indicate that the arrows are showing, I mean, the right direction, unlike Amos output that is showing that arrows are, you know, moving from right to left. This one is moving from left to right.
Yeah, so that little nuance there, a lot of people don't pick up on that. You may have noticed in Amos, the arrows go from right to left, backwards. And in this one, they go left to right. Here's the logic behind the backwards arrows. When you say you're regressing upon something, you say it backwards. You say, even if you have X affecting Y, it's actually Y being regressed upon by X. And so you change the arrow direction. But that's a statistician's design instead of a user's design. This is user designed a little bit better because this is how we think of it, left to right. Okay. Oh, was I muted for that? Nope, I'm good. Okay, view. Okay, so you can see all the p-values of all the paths. We can see that the path from, for example, experience to comprehensive use is significant p-value of 0.001. And we can even export this to Excel. If I were to click on export Excel format, it will copy it to the clipboard. And now I can paste it in an Excel file, like right here. I can go paste, and there's that whole table right there that we just saw. Again, that was copy to Excel. Or if you're using R, you can copy it to R. Okay, now if you run the bootstrap and you go back and look at your model, these values look all skewampus. It's because they're not regression weights, they're t-statistics, they're the critical ratio, the critical value. So typically, anything over about 1.96 absolute value is significant at the 95% confidence level. So we look around, all of these look pretty significant. This one here, not significant at the 95% confidence level. This one here, no effect at all. How about from experience? Experience does seem to have an effect on comp use, but it doesn't have an effect on usefulness. Interesting.
So anything about 1.96?
1.96, yeah, for 95% confidence. For 90% confidence, it's 1.65. For 99, it's 2.58.
It's 3.96.
For 0.00, yeah, whatever, yeah. Okay, so that's that. That's how you assess a causal model, roughly speaking. We haven't done mediation, moderation, or anything like that yet, or a factor analysis. We can do that. Any questions about that before I move on to factor analysis? Okay, it was pretty easy, right? Way easier to start up than Amos, I think. But maybe it's because you already used Amos and you're like, oh, yeah. It's like in calculus when they teach you how to do things the hard way first, and then, anyway, okay. So to do a factor analysis, we need to assess the outer model. Right now we're assessing the inner model. Let's assess the outer model. For a reflective model like ours, we have the same sort of criteria. Let's go ahead and just run the PLS consistent algorithm. Hopefully it'll work. Hit start. Oh, sorry, no. If we're assessing the outer model, sorry, let's run this one more time and close this. My bad, go back to the model. When you do the consistent PLS algorithm, there's some settings we should change if we're doing a factor analysis. We should check the box for connecting all LVs. Again, for a reflective model. If you have formative factors in here, maybe not so important to check this. Partial least squares, we're going to change it to a factor weighting scheme because we're looking at the factors or trying to understand them. And then that's the only other thing we change. Hit start. It runs the analysis. And before we look at the output, let's go back to the model. And we get to see these loadings. Let me pull these out. Oh, one at a time. I don't want that. You can actually select. Used to be able to select. There we go. And click and drag. Oh, it changes the model. I was just trying to get more room in here so we could see our loadings. I'm still going to do it this way. Sorry, I'm just making it so that we'll be able to see the loadings a little better. Okay, and I'll calculate it again. Start. Okay, here is our model. Here are our loadings. The same rule applies as for Amos. We want to average out above about 0.7, and we want, and we don't have any correlation values actually, although they are produced. We'll see them in a moment. But that's the main criteria. We want to average out above about 0.7. So we look over here, looks good. Look over here, we have a Haywood case, but otherwise we're pretty good. Here, about right. Here's good, and here's good. We can know for sure if we look at the output. If you go to, at the very bottom here, you'll see there are all these options. If we go to outer loadings, if we had formative factors, we'd use the weights. We're going to look at outer loadings because we have reflective factors. When you click on that, it shows you your pattern matrix. There it is. Here, oh, age you can ignore because it's not latent. But here's how it all loads. And the way it does it is it marks it if it's less than 0.7. Because less than 0.7 is bad. Ish. It really ought to do it at a better threshold, but a lower threshold. So you can see there are a few that are less than 7, but they're not that far below 7. 0.6, 0.6, not a problem. Go back up, 0.6, 0.6, not a problem. Again, ignore these single factor ones or single indicator ones. They're not relevant. We can also look at the latent variable correlations. That's this one right here. Right under outer loadings, look at latent variable. And this is the correlation matrix, which again, you can just export anything you see here to Excel or as a table format. So there are correlations, and we can see that none of them are greater than 0.7 except this one here, decision quality, information acquisition, greater than 0.7. Just barely. So there might be discriminant validity issues there. If we want to know for sure, there's actually a discriminant validity table that's produced. How about that? Discriminant validity right there. Don't have to have a plugin for it or any Excel tools. It just is built in. Here we go. Yeah, wouldn't this be nice? Here's the discriminant validity. Look, it's the Fornell-Larker criterion. That's the square root of the AVE compared to the correlations. And if there were a problem, it would show in red. And we don't see any red, so we're good. Or we can eyeball it and just say, okay, where's our lowest one? 0.729. And it's compared to all these correlations. It's good. The one that we were having trouble with, decision quality, information acquisition, 0.709 compared to 0.725 and 0.808. We're good. There's no discriminant validity issue. And if we really, really wanted to be sure, go to the heterotrait monotrait, HTMT. And this is another test of discriminant validity that says how much of the variance in my variable, in my factor, is explained by my indicators, and how much of the variance in my factor is explained by other indicators. Am I a single thing, or am I being explained by multiple things? Heterotrait, monotrait. And if you have values less than 1, you're good. If you have values more than 1, it'll turn red, and essentially you have no discriminant validity. We're good. What if we weren't good? Then what? Let's pretend, see this 0.711, this is our highest value here. We could fix this by going to cross-loadings. Okay, here's the full fact unguided pattern matrix. What we need to do, let me zoom out. And here's information acquisition. Oh, whoops, I just sorted. Can I unsort? I can't unsort. Dang it. Oh, that's unfortunate.
Can't undo.
Can't undo that.
Control Z.
If I go to a different tab and then go back. Dang. Oh well, there's no Control Z. Well, let me just rerun it. It'll take a second to rerun. Start. Okay, back to discriminant validity, cross-loadings. Here's the playfulness, not playfulness, information acquisition. I go down to decision quality here as these ones. Let me export it to Excel. It'll be easier to look at it. Here it is right here. And in this column, I'm going to see the biggest ones. There is a new tool in Excel that lets you do local formatting. Where is it? Draw page layout. No. Insert. I can't remember what it is. There's a local formatting, which is kind of nice, but I can't. Oh, format as table? No. Oh well. Okay. But I can look here where decision quality crosses it, which is right here. And I can see which ones of decision quality load strongest on information acquisition. Turns out they all load about the same. Well, dang. Well, let's go the other direction. Let's go look at decision quality. Here's decision quality. And let's go look at information acquisition, which is right here. And let's see which ones load the most. Aha! It's this one, 0.6. And that belongs to information acquisition 4. That's the one. So if I were having trouble with discriminant validity, if my HTMT produced a value above 1, or if my Fornell-Larker failed, I would go into SmartPLS, go to number 4, information acquisition 4, and I might delete this one and see if that separates them more. And that's it. It's nice and easy. So that's discriminant validity. Convergent validity, if we go to the output, we can look at construct reliability and validity right here. It's this link above discriminant validity. And it gives you the Cronbach's alpha and the composite reliability and the average variance extracted, AVE. So my Cronbach's alphas are all green, meaning good. My composite reliability, all green, all good. It should be above 0.7. AVE is all above 0.5, all good. If they're not good, what do? In the case of these convergent validity things, you remove the lowest loading item. So let's look at our lowest AVE here. It's information acquisition. So if I go back to the model, It would be number 5. I might remove number 5 because it's a 0.6. So we'd be minus these two. We'd have just information acquisition 1, 2, and 3. And we'd probably have a more solid factor. That's convergent validity and reliability. Those are easy. And yeah, method bias. We can do method bias. Yeah. In a moment, we'll do method bias. We also want to look at model fit, right? Even though model fit's not really a component of partial least squares, if your reviewer says, but what about model fit? Because some reviewers say, I must have model fit regardless. Well, there is a model fit link anyway, and you can look right here at your SRMR and produce no chi-square and no NFI. If I rerun this as not reflective or not consistent, it'll probably work. So let me go run this again as PLS not consistent.
So the reviewer challenge me.
You can run it in any way.
Yeah, really you should run it as consistent if you have all reflective, but if it breaks, you gotta go back to the other method. Here's model fit. It did produce values for us this time.
How reliable are these?
Sorry, what?
How reliable are these values?
How reliable are they? It's for PLS, and it's not a covariance-based system, so.
Will be great to be able to compare what the different Amos and PLS see.
Oh yeah, they will be different in Amos and PLS because they're different constraints, different parameters. I read an article. I think it was Joe Hare who wrote this, and he said something along the lines of, I'm paraphrasing here, but he said something along the lines of, first off, if you're going to have all reflective factors, don't use PLS. Use some Amos or Lizerl or something. If you're going to have all reflective factors, then PLS is the wrong software. If you're using PLS, then you have formative factors, and model fit is irrelevant. So is method bias. So use the right tool for the right data. They've forced a square peg in a round hole here with model fit in PLS.
Why would method bias be irrelevant for formative?
So because formative factors are not all identical, they're robust instead of redundant. Method bias has less effect on their inflation because it's not you're not asking the same thing over and over again. So there's very little inflation due to that. That makes sense. Yeah, instead of yeah.
What is RMS theta?
RMS theta?
Yeah.
Oh, up top. I don't know. Is that new? Cool. I don't know what that is. I could look it up. But if you wanted to use these, SRMR is supposed to be less than 0.08. In this case, it is not. So let's see if we can fix it. Chi-square has no minimum threshold because it's dependent on the complexity of your model. Our chi-square in this case is 1700. The other ones, don't worry about. They're still actually in the literature trying to resolve what they mean and how to use them. NFI is old. It's supposed to be greater than 0.9. Ours is not. So let's see if we can fix it. We know in our model that there is a relationship between information acquisition and decision quality, and yet we're not accounting for it. So let's account for that real quick. Click with the connect tool. Run it again. Look at model fit. Lo and behold, I am now under 0.08. Yay. NFI hardly changed at all. I don't like NFI. But neither does PLS, so we're good. So I use SRMR. If I ever have to report model fit when I'm using SmartPLS, I just report the SRMR.
When we're doing the model fit, we're using the factor or the path?
It depends on which model you want to assess fitness. I'm assessing at the factor analysis, the measurement model, so that'd be the factor level. Will this change if we use path? I actually don't know. I assume it would be fairly consistent. Let me try. Yep, it is identical. Okay, we're going to take a 2-minute break, and then we'll come back to this and do mediation, moderation, multi-group, second-order factors if we want. We'll do some other stuff. Method bias, even though it's supposedly irrelevant if you're using formative factors, but we're not. Okay. We should also test formative factors. Okay.
No, you good. I'll let you. Please.
I'm trying with my own data. My ABE is the worst.
The worst.
Yeah. Every endogenous variable is a different scale. So I was trying to.
Are they formative or reflective?
All the items are reflective. Well, I understand, right?
So connect all LVs since they're all. All right, reliability and validity. Okay. And your ABEs stink.
Yeah.
They're so bad.
Gaslighting is not that.
So let's go back to the model. Terrorism. Yeah. And then display your indicators. And maybe rotate them around so we can see them. I've used right click. Oh, sorry. So right click a factor, and then that's weird. You click it and then right click, left click. Right, we'll try left click. Oh, you're on connect. Just select. All right. Okay. All right, align right. There we go. And then we'll be able to see some. And then align block.
All right. Now let's run it.
We'll be able to see things. Run your algorithm. Okay, let's go back to your model. Okay. So you have some issues for sure. Negative loading. So the question is, what is that question? And what is that question? And two. What are these questions? And are they truly reflective or are they formative? We're going to do a formative model in just a minute.
Yeah. Great.
Usually, if they don't load together, they're not reflective.
Yeah. So at the end, I can make an article about how those scales are maybe using formative. And okay.
And you can even compare models if you want. Yeah, say here the error is reflective, here the error is formative. Look, so much better as formative. Maybe. Okay.
So I get something there.
Yeah.
It's not that easy. First day I was like, oh, that's easy.
Nice. She liked this so much.
Yeah.
But her rest advisor may not have good issue.
Yeah, for sure.
For sure.
Probably, yeah. Is it her advisor is Phil, right?
Sure.
Or Sherry? Yeah, maybe not. I don't know.
So what can she do?
Ask.
Can she switch to you?
No. As her quant advisor, sure. But
We're talking about quant.
but
Okay.
but not about capstone.
No, we're talking about capstone.
Oh, talking about the quant paper. Oh, well then she should be okay. Sure, she'd be okay with it.
Oh, really?
Yeah.
Because even capstone, I don't use Amos. Remember we talked about before. I don't mind using Amos.
No, but for the quant paper, she can use SmartPLS. That's fine. Just ask Sherry. That's all.
Say yes.
Oh well, yeah. If you want for your quant paper to use SmartPLS, go for it. Just ask Sherry. Just make sure she's cool with it.
I'm sure she'll be fine.
Yeah. Then we're good.
It's big, you can't use it for, can't use it
Not for the capstone.
Yeah.
Nah,
Yeah.
even me, I use Amos.
No, but that's cool. I mean, it's like,
It's so easy, right?
it's easy, and you click, and
And-
you get all the data you need.
And the
Amos is manual.
yeah, it is automatic.
Yeah, this one's
It's,
like, that's right.
I had to try to patch together Amos to make it automatic, and it's still clunky.
No, I mean, you helped tremendously. We were just talking about that at lunch. I mean, not at lunch, before the break, for the morning break. You've made it so much easier.
Well, you should have been here 5-6 years ago, back when it was all like we were doing formulas in Excel, trying to calculate the AVE in Excel and calculate the CR. And
Because this guy, we don't need any plugins.
no, you don't need any plugins for SmartPLS. It's all built in already. It's because they just built this 2 years ago, the newest version, and so they had all the complaints about Amos already, and they built it based on that. Okay, are we missing? I think we're good. Okay, we're gonna get started again. So that was factor analysis, except we didn't do a formative factor analysis. So let me show you formative real quick. If we go back to our model and we pretend something is formative, what's gonna be the most formative thing? Probably comp use, anxiety. None of these are actually formative, so I'd just be making something up here. Let's just pretend. Let's pretend anxiety is formative, yeah? All right, the way you model a formative factor is you switch right here. You right click the factor and say switch between formative reflective. It is now formative. You can see the arrows. Yeah, the arrows now point at the factor. And when you analyze it, we will not use consistent. We'll use just the regular PLS algorithm. If we're doing a factor analysis, we'll look at the factor and start. Look at the output. And instead of looking at the outer loadings, we look at the outer weights for that particular factor. Everything else we look at the loadings. But for this factor, since it's formative, we look at the outer weights. If I click on that, and I go down to, was it anxiety I flipped around, I believe? Anxiety. You'll notice these weights are all messed up because it's not truly formative. I just made this up. A truly formative factor would hopefully look better than this. But you would expect roughly equal weights. You don't want drastic differences like -1.1 and -2 all the way up to +0.79. It's kind of wild. You'd want roughly consistent weights. And then you
0.7 range.
Anywhere between 0.2 and 0.8-ish. Yeah. And you'd also want them all to be significant, significant weights. So to check that, you got to go back to the model and run the bootstrap, not the consistent bootstrap. Just run the regular bootstrap, hit start, wait for it to run. Oof. Still running. There we go. Okay. And what you look at is, excuse me, you look at the outer weights again, and here are the p-values for those outer weights. We were looking at anxiety, which is our first batch here, and we want all of these to be significant. Turns out only a few of them are. Now in a truly formative factor, we'd probably expect more significant indicators. But let's assume this is our formative factor and we have a p-value of 0.627. So clearly not a meaningful indicator for this particular factor. What do? In a reflective factor, you just delete it because it's all redundant anyway, right? In a formative factor, not so, because It's like the analogy with the bread. You take away an ingredient, and that's not bread anymore. That's a bagel or a cookie or a biscuit, and it's no longer bread. So if I take away this anxiety 4, it's going to change the nature of the construct. So you have to make a decision, an executive decision. By removing that one, what does the construct become? Is it still something I can use? If yes, then maybe we can remove it. If not, we leave it in and just say it's a nominal contributor to this factor. But it's not significant. One other thing you need to do with formative factors is you need to look at their variable inflation, their VIFs. To do that, you got to go back to the regular PLS algorithm and look at the collinearity right here. Collinearity statistics, VIF. Click on that, and that'll show you the VIFs. And now we're just looking at anxiety. Oh, interesting, interesting. 1, 2, 3, 4, 5. Anxiety 5 is giving us trouble. Anything over 5 is considered bad. Anything over 3.3 is considered, anything over 3 is considered moderate. Anything less than 3 is fine. And they color code them, green, black, and red. So in a formative factor, you don't want multiple indicators being highly multicollinear, because then you're inflating one dimension of that factor. You want equal representation among your dimensions. So if this were truly a formative factor, I would look at this and be like, oh, anxiety 5, that's too similar to its other indicators. I might go read the items and figure out why, but then in the end, I'll probably end up deleting that one dimension right there, anxiety 5, with the full justification that it was just multicollinear. Therefore, it was redundant. Therefore, it was unnecessary. It was not contributing meaningfully to the robustness of the formative factor.
What would be the differences as outer? I think you covered this already, but is outer VIF and inner VIF?
Yeah.
Outer and inner?
So the outer VIF is from factor to indicator, or indicator to factor. It's between factors and indicators. It's the measurement model. Inner VIF is between latent variables. So we did this with SPSS, where we can look at all the predictors of decision quality and look at their VIFs to see if they are too high. As long as we're here. Nancy, you asked about method bias. This is how you check method bias in SmartPLS with the VIFs. Yeah. So here are the inner VIFs. That's the one you want to look at, inner VIF. If anything is above 3.3, that's Ned Cox threshold. Anything above 3.3 indicates potential method bias. So we're good. We have no method bias. Done. That's it.
So if VIFs are very why do we check for multicollinearity?
So good question. For those remote who didn't hear that, if repeat is I'm trying to figure out how to read it. There's a difference between VIFs for the construct and VIFs for the model. So the inner VIFs is between constructs. We got to check for that for multicollinearity to make sure we don't have an inflation of R square. The outer VIFs are for the factor themselves and their indicators, the factor and their indicators, to make sure that no particular dimension of a formative factor is being overrepresented, which would be indicated by multicollinearity, VIF. We don't check that for reflective factors because we expect them to be multicollinear. They're redundant variables. They're supposed to be like that. Yeah.
So no CLF, no marker variables.
No marker variables, no stupid specific bias variables, no CLF. You just check the VIFs.
That's all.
That's it. Done. And cite Nedcock, 2012. Yes.
James,
Yes.
can you impute factor scores for the formative factors in PLS?
Heck yes. You want to see how?
Yes, terrific.
Okay. If you want factor scores for the formative factors, then what you do is you go to, here it is, you run the PLS algorithm, and then you click on down here, latent variable. This latent variable is the latent variable score. And if you scroll through this, you'll notice we have 378 rows. This is the factor score for all of our respondents. So we could just copy this out to Excel and then paste it on our data set. Let me go do that right now. If I go to our data set, and I'll repeat myself because I realized I went kind of fast there. But if we go to the data set, the CSV file we created, we can literally just go to the end. It's in the same order, paste these latent variable scores in for age, anxiety, all this stuff. And it is exactly the number of respondents we had. These are the factor scores. And the formative one was just this one right here, anxiety. But again, how do you do that?
Yeah, terrific.
You run your PLS algorithm.
Terrific.
Sorry, go ahead.
So I'm just saying that for anyone who wishes to use AMOS and they have accidentally created formative factors, it's probably a solution whereby they could impute factor scores in PLS and go put them back into SPSS and then reuse the whole thing in AMOS. No?
Yes, you're exactly correct. If you had accidentally created formative factors and you needed to use AMOS for your analysis for whatever reason, you could start with your model in SmartPLS, then export these latent variable scores, and then in AMOS, you would just have a single variable for anxiety for that formative factor. Good point. So it's super easy like that. Okay. And we're plowing through SmartPLS. It's pretty easy. You want to see how easy it is to create an interaction? Check this out. Yeah, moderation here. So we had experience moderating the effect from playfulness to usefulness and from anxiety to comprehensive use. To make this happen in SmartPLS, you right-click the endogenous factor using the selection tool here. You right-click the endogenous factor. I'm going to right-click usefulness. And you say add moderating effect. Easy peasy. What is your moderator? Experience. What is your independent variable? Playfulness. What approach do you want to take? We're going to use the two-stage approach. That's where it's going to create a factor score for experience and for playfulness, and then it's going to standardize them, and then it's going to multiply them together, just like we did in SPSS already, but it does it all together right here. And I hit OK, and there it is. There's my moderator, my interaction. If I were to open this up and show the indicator is playfulness times experience, but standardized. And that's it.
So we don't need to calculate from SPSS.
No, you don't have to take it into SPSS, save descriptives, save standardized values, multiply it, save, recreate the data set, relink it to here, multiply. Yeah, you don't have to do all that. You just do that. Right click and select. It's great.
I'm beginning to think that this was, I did not choose wisely staying here because I'm just.
Now you're feeling bad you have to use AMOS, yeah? Anyway, you run this, hit.
I was blissfully ignorant until now.
Yeah. I'm going to change this to path analysis.
But the question is there is no question about AMOS.
There's no what?
No question about AMOS.
No, so AMOS in the literature is well established and validated.
Right, yeah.
Whereas SmartPLS, people will still say, why are you using SmartPLS? Why not just use AMOS? It's getting there.
The most advantage is small sample. We want to talk about.
We'll talk about small sample and normality issues. Sure.
So there's some that you click on and it doesn't give you the opportunity to do
Yes.
a moderating effect. It wants to ask for
Yes.
this quadratic.
So you cannot create a moderating effect on any exogenous variable. It has to be endogenous. Anything that's already being predicted can have a moderating effect. So anything on this side of the model. But anything on this side of the model cannot have a moderating effect. To run this, all you do is hit go to PLS algorithm, run it, start, and here are the effects. So I'm gonna go back to the model. The effect is negative 0.050. Nothing really going on. If I want to see what that really looks like, do a bootstrap and run. It'll even create a graph for me. You don't need my Excel tool for this. It has one for you. Yeah, it's great. Just takes a moment.
4.0.
Doesn't do it, yeah.
Doesn't do it.
Yeah, version 3 is really nice.
I think I only had a little to say.
Yeah. Here we go. Okay, let's look at the output. So the effect from the interaction, which is right here, not significant, 0.308. And then if I go back to the original run, I can look at the simple slope analysis right here. It's at the very bottom of the left column, simple slope analysis. This shows me the interaction. This is the interaction effect. It's kind of ugly. I'm going to take it out. Actually, I'm going to copy it as a chart. And I'll just paste it in Word, actually. Let's see, where'd my Word go? I don't have Word open? I don't. Okay. It's got ugly formatting in SmartPLS, but if you take it to Word, it formats just fine. Paste this in here. There you go. So the green is high experience, the blue is low experience, the red is middle experience, and it looks like experience dampens the positive relationship between playfulness and usefulness. So playfulness affects usefulness less strongly the more experience you have with Excel.
How do you interpret that from looking at that?
So I saw that the high value, the green, which is high experience, has a shallower slope than the low value, which has a sharper slope. Yeah.
Okay.
So the slope gets gradually lower as experience increases. Yeah. Anyway, that's kind of nice. So you just paste this into your report and bada boom. Version 3.4 or something will maybe have the interpretation in there for you. Okay. So that's interaction. Super easy interaction.
So fast.
So fast.
Just 10 minutes is okay.
Yeah. It's great. Okay, I'm going to go ahead and take out this interaction. It's no longer relevant to my model. I'm just going to click on it and hit delete. Let's do multi-group. I'm going to get rid of experience here. It's not part of my model anymore. Multi-group is easy enough. Here's what you do.
All of your factors are formative now, James, aren't they? As you have them there.
They're all reflective except anxiety. Let me switch anxiety back. Thank you. Okay, now it's reflective. Oh, except decision quality. And oh, whoops. Oh, you were making a note that they were all formative. Whoops.
Yes.
I don't know how that happened.
When you did it, you did it for all.
Oops. Thank you for catching that. I'm going to switch back. There we go. Now they're all reflective, except decision quality.
So that means that the result that we initially had may not be consistent.
I think we did the original factor analysis with them all reflective.
Right, yeah.
It was just once I switched anxiety, apparently they all switched. Whoops. Okay. Did these switch too? Not that these matter that much. These are just one. Yeah, they switched. Okay. Here we go. I'm going to save this. Multi-group. What you do is you go to your data. If it's not still up here in the top, you can just double click it and it'll pop up right here. And what you double click the data set here and it'll pop up as a tab here. Okay. You can either generate data groups automatically or you can add data groups manually. Our data can easily be generated automatically because they're just two values for gender, 0 and 1. So I go click on generate data groups and I'm going to have the prefix be gender underscore. And I'm going to get it from gender here. This is alphabetical order, so just go find gender right here, 2 unique values. And that's it, actually, just that. Yeah, let's see what happens when I do that. There we go, created 2 genders, 287, 291. And now if I want, I can go edit these and call it male and female. So I click on edit, call this one male, and hit OK. And I call this one edit female. Okay. But something super cool, check this out. If you want to add a group that's not categorical, you need to like split your data along something like, let me show you. Here are the indicators. What if I wanted to create something for these early adopters or for frequency or experience? We had experience as a an interaction, but what about as a multi-group? Or experience, the mean and median are 4.3 and 3. I'll use 3 as the split. Check this out. I'm going to add a data group manually, call it low frequency. And I'm going to say, well, for frequency, it's got to be lower than 3. And then lower than 3, hit OK. And then I add another data group. Call this high frequency. And it's got to be frequency greater than 3. That's going to exclude anyone who was a 3. There we go. And now if I look at data groups, I have high and low frequency. Looks like low frequency isn't very well represented. I should have changed that. Maybe edit this one and make it is lower than 4. There we go. That has 63 people in it now. And now I have these groups that are automatically generated. I didn't have to go create the variable, save it, and all that. It just does it on the fly like this.
That was going to be my next question. I've noticed that you haven't saved iterations.
No.
Like we have done in Enos. So it just.
The model's there. I can save versions of it if I want. I can duplicate this model, for example. I can right click this and hit duplicate, and then have a new model, and then a new model if I want. Yeah, to keep track of what you've been up to. But we need to do multi-group. So let's do a multi-group, and we'll just do it with male, female. So let's go back to the model here. And what we're going to do, we're going to calculate and just do multi-group analysis right there. Calculate multi-group. And you just select the groups. Oh, that red is really hard to read. Female in this group, male in this group. Those are our 2 groups. And hit start. And it's running a multi-group analysis. That was it. And it does invariance for you.
So now it's comparing males and females?
Males and females both on the outer and inner model. So it's doing all the measurement invariance and the causal differences.
Would they compare the means also?
Maybe. Let's check. Just a sec. Still running.
Can you make the circles into ellipses?
No, you cannot change the circles to ellipses, I think. No, cannot. So Amos is better.
That's what Tony says.
All right, here we go. It finished. But check out this is good stuff. Here are the bootstrap results. I'm gonna have to open up all of the. Gonna expand this. This is the female group. This is the male group, and here are their effects. And here is the difference. No, that's the mean. Where's the difference? Male. Oh, it's over in MGA probably. So here gives the p-value for female, p-value for male, so we can see the differences, but it actually calculates the difference between them if you go to the PLS MGA tab. So here's the path. Here's the effect of female minus male, absolute value. And here's the p-value for that difference. This is essentially like my estimand in Amos. And so it says, yeah, here are all the paths, and none of them are significantly different between men and women. All those p-values are non-significant. But if there were any significant differences, it would show you right there. And you could say, well, did I have invariance? Well, go to your parametric test. Nope, that's not the right one. Wait up. Where'd it go? I might have to run the bootstrap on it. Dang it, where'd it go? Nope. Outer weights, outer loadings, outer loadings. Here it is. Outer loadings, parametric test. Here it is. This is there a metric difference between men and women? Metric invariance. And the answer is, in the case of anxiety 7, maybe it's 0.096 p-value. Everywhere else, nope, we have metric invariance. All these p-values are non-significant. So that's metric invariance. All that pain we went through yesterday for metric invariance, it's just a click of a button here. Yep.
If you want scalar invariance?
Now, if you want scalar invariance, I don't know. Actually, it does produce the means right here.
It does.
Yeah, the means right here. Here. Mean. No, but that's the, never mind, that's a different mean. That's the mean for the bootstrapping sampling. Yeah, that's not the mean or the intercept. So I don't see any means or intercepts here.
Whether they compare the difference of the mean of both groups, you can say the standard deviation or different.
You could, yeah, go look at those standard deviations. I wonder, I just want to check one more thing here. Here. Interesting. Nothing. Okay. That's MGA. That's multigroup. That easy. So multigroup analysis is no problem. What have we missed? Let me go look at my slide here. Effect sizes. We haven't talked about that.
Right.
Okay. Effect sizes are calculated for you in SmartPLS, just like everything else. If you go to, not in an MGA, let me get out of MGA. Go back to my model. Just run a regular PLS algorithm. I wonder if I have to bootstrap. I might have to bootstrap. Let's see. Nope, they're here.
Factor or path?
We should do path on this one for effect sizes. And if you do effect size, if you do path and you do regular PLS algorithm, you get this F square here, and that shows you how big are your effects, and it even color codes them for you. So all the effects on decision quality are nominal except information acquisition. All the effects on information acquisition are nominal except usefulness.
Does it include also the degrees of freedom?
Degrees of freedom are in the model fit area, I believe. Nope. The thing is, degrees of freedom are based on the covariance matrix.
Yeah.
So I guess not. Let me go back here. You also get the R squares if you're wondering what they are for your endogenous variables. There are all the R squares. There's that. That's effect sizes. Mediation? We didn't do mediation, did we? Okay, mediation. Super easy. I actually called them up and said, hey, can we get specific indirect effects in the next version of SmartPLS? And they said, sure. And they did it. It was great. So I can take credit for this feature. Yeah, because they didn't do it before. And I was like, yeah, this is a real limitation of SmartPLS. And they said, oh, we'll fix it. So they fixed it. So if you go to the output here, and you look at indirect effects, not the multi-group. I got to run it again with bootstrapping because it's mediation. So let's do bootstrapping and do it on path here. Start. Bootstrap, gone to bootstrap. Here we go. And if you look at the indirect effects down bottom here, it says indirect effects. Oh, that's the histogram. I don't want the histogram. I want the specific indirect effects. They added that. Specific indirect effects. Here they are. For every possible specific indirect effect, here's the p-value.
I like that.
Yeah. And there it is. I mean, that's it. What you look at is the sample mean, not the original. Sample mean estimate. And the ones that are significant, like this one, playfulness, information acquisition, decision quality, that is significant. You report that sample mean and that p-value. Specific indirect effects, that's mediation. All done. I love how fast that is. It's just done. It's part of it. Interaction we did, multi-group we did, method bias we did, formative models we did, multicollinearity, yes. We didn't do second order models. I can show you that real quick. Categorical predictors. I'm not real chuffed about that. And model fit we did. So it's really just second order models. And then we're done. Woo! Okay, second order models, here it goes. You have to use what's called the repeated indicator approach. So let's say information acquisition, decision quality were the same thing. Part of the same latent factor, higher order model. I would put a new latent variable. Oop, what the? Hey, look at this. I can make an ellipse.
Oh, look.
Okay.
Would you know if I did?
Oh, so that's why you were.
I didn't even know you could do that.
Okay. So I'm going to call this
I mean, I'm
system
not going to, but-
satisfaction.
Yeah.
System sat. And hit OK. And then I have to give this system satisfaction all of the indicators. This is called the repeated indicator approach. You give it all of the indicators that are part of its constituent variables. So this would be all of the information acquisition and decision quality right here.
Professor, which one is better, repeated indicator approach or two-stage?
They're both. So you actually use the repeated indicator approach in the two-stage approach. Does that make sense? So the two-stage in this case is different from the two-stage we were talking about before. Two-stage for repeated indicator is you repeat the indicators in the measurement model, and then you extract latent variable scores, and then you put the latent variable scores in instead of the indicators. So that is the two-stage approach, and it uses repeated indicators. Anyway, but then you connect this to its constituent ones. I'm going to go ahead and remove these arrows that are no longer relevant because you shouldn't be. Oops. Control Z. Love that. There we go.
You can control D that. You can't control D the source.
Yeah. Oh. So I shouldn't be predicting the dimensions of a second order factor. I should predict instead the second order factor itself.
Why haven't you turned on?
Because these are no longer connected. Come on. I know you're there. There we go. And then I'm going to connect real quick this to this, this to this, this to this, and this to this. Boom. So now we have repeated indicators. I can now run this as a second order factor. Yep. And because it's reflective, I can actually just take one stage. I don't need two stage. If this were a formative second order factor that was being predicted by other things, you'd have to do the two-stage approach where you extract the factor scores and use those instead. I have a video on that if you want. But here's the second order factor. You use the same criteria as you do in a first order. So if I go over here to the output and I go to the discriminant validity, same criteria for system satisfaction, which is right here. It looks good. Heterotrait, monotrait. Says it's not different from decision quality and information acquisition. That's because those are its dimensions. So that's not a problem. And then constant reliability and validity, it's all good. That's second order factors, super easy. Okay. That's all of SmartPLS I want to show you. Just to get you interested and see what is. Oh, you were interested, yeah. If you want to learn more, you can go to this playlist. It has 17 videos, goes over everything I did today plus more. You have a 60-day trial for free. It's the full version.
Can I use this license key next year?
No, it only works for 60 days.
Yeah, but
Oh, you haven't used it yet? Maybe you can use it next year. I don't know. I think so.
Can you use it after the 30-day trial? Extend it to 90 then?
It's a 60-day trial, the one I gave you. But yeah, you could use it after you've done your 30 days, I think you can use this as your 60 days.
You get 60 more days.
I think so.
But I mean, still is like $240 for the year.
Yeah, for the whole year. So your institution can pay for it, hopefully. Or you can. All right, any questions about PLS? We didn't talk about briefly why to use it. You use it if you have formative factors.
Yeah. Small sample size.
There are arguments for small sample size and non-normal distributions of your data, but those two things, while SmartPLS can run them, whereas Amos cannot run, they just won't run. Amos will give you weird output. SmartPLS will run, but it's still limited by the limitations of small sample sizes and non-normal data, because it's still regressions. So, more error. Any questions? I can see we're antsy. People ready to go?
Last question for you.
Yeah.
Preference between Amos, your preference.
My own preference?
And SmartPLS.
Which one do I use more? I use Amos more. Because it's easy for me. I've written all the plugins. I can just zip through it. And I know I'm not going to get fought when I submit it for review. Yeah.
It's long enough.
But I have a paper right now I'm writing that I use SmartPLS for. So I use both. Anything else?
You can use it, like you said, for reflective also.
You can. But Joe Hare says, if you got all reflective, why are you using SmartPLS anyway? Because it's easier. I'd love to see that written in the paper. I use SmartPLS because it's more functional.
It's more personalized.
There you go. More efficient. It provides
For
more features.
factors, can I use Amos?
You cannot use Amos for formative factors. Cannot. That is
So
this
just make
hard
sure your
limitation.
model includes a formative
Formative
factor.
There you go. Yeah, make sure it includes it.
For why I learned the smart.
Yeah. Okay.
Updated for the version 3, or is it still?
Version 3 is out and available.
The book.
Oh, the book. The book, yeah, it's updated for version 3. It's called A Primer on SmartPLS, or Primer on Partially Squares Modeling. Yeah. The 2016 book, I think. Yeah. I will stick around if anyone needs any one-on-one, but then if you're good, we're good. I'll go home and get some rest.
Thank you very much.
You're welcome.
Thank you.
If you want a certificate, make sure you email me. I'll send you one.
So, Professor, how will you send this already?
How what?
How will you
Don't
send
be
this?
exact, thank you.
All the videos?
How will you send this certificate?
A certificate? I'll email it to you. A PDF. I'll email you a PDF. Yeah.
We do it crayon?
In crayon. I'll have my daughters make the certificates.
No?
No.
I want mine to like all of them.
Thank you. You're welcome. Thank you.
Thank you.
Good luck on your capstone, guys.
Thank you.
Yeah. All right. Remote folks, are you good? You need anything?
We'll see you in
James, do we have access to Google Drive for a short while more? Your link, does that say live for us?
Have you not had access to Google Drive this whole time?
I have, yes, absolutely have, yes, but I'm
Good.
just wondering, when does that shut down?
Oh, it will never expire. You'll have access forever.
Okay, thanks for everything, and I look forward to this time next year. Thank you.
You're welcome. Hopefully you won't have to attend it next year. That'd be such a shame.
No, you always learn something, and I think that's clear.
Okay.
Thank you.
I appreciate it. Thanks. See you.
Bye.
All right. Anyone else remote need anything? Otherwise, I'll stop recording. Okay.